Do I need to use one_hot encoding if my output variable is binary? I am developing a TensorFlow network based on their MIST for Beginners template. Basically, I am trying to implement a simple logistic regression in which 10 continuous variables predict a binary outcome, so my inputs are 10 values between 0 and 1, and my target variable, y_train and y_test in the code, is a 1 or 0. My main problem is that there is no change in accuracy no matter how many training sets I run. It is 0.276667 whether I run 100 Oregon 31240 steps. Additionally, when I switch from the softmax to simply matmul to generate my y values, I get 0.0 accuracy, which suggests there may be something wrong with my XW plus B calculation. The inputs read out just fine. What I'm wondering is A, whether I'm not calculating y values properly because of an error in my code, and B, if that's not the case, is it possible that I need to implement the one_hot vectors, even though my output already takes the form of 0 or 1? If the latter is the case, where do I include the one_hot equals true function in my generation of the target values vector? Thanks.
Since you map your values to a target with one element, you should not use softmax cross-entropy, since the softmax operation transforms the input into a probability distribution, with the sum of all probabilities equal to 1. Since your target has only one element, it will simply output 1 every time, since this is the only possible way to transform the input into a probability distribution. You should instead use tf.nn.sigmoid_cross_entropy_ with _logits, which is used for binary classification, and also remove the softmax from y_opt and convert it into tf.sigmoid for y_opt_test. Another way is to one-hot encode your targets and use a network with a 2-element output. In this case, you should use tf.nn.softmax_cross_entropy_ with _logits, but remove the tf.nn.softmax from y_opt, since the softmax cross-entropy expects unscaled logits, this URL. For the y_opt_test, you should of course not remove it in this case. Another thing, it might also help to take the mean of the cross-entropies with cross_entropy equals tf.reduce_mean tf.sigmoid_cross_entropy_.
If you want to see more, please consider subscribing.